All right, before we move on to the table, there are a couple of features that need to be done to this to complete it. Simple features. There's a hole in the side here that goes all the way through, and there's a hole in the back that goes through this web and intersects this hole as well. Now, as simple as those features are, there's really no way to place this hole. It's always the simple features that get you, right? Here's your reference plane right here on the inside of this rib. That also needs to be machined back. So after I finish machining this face right here on the inside, I'm going to mark it right there, effectively removing that piece of flash as well. I then need to locate a hole in the side from that, but here's the problem. When you clamp it, you can't get to that. So this is one of those features that you better think about ahead of time. And it's also dimensioned from the top of this rib right here. And look at that. 330 seconds up. 090, that's about what, 2¼ millimeters-ish. 16th hole. So we got to come up and we got to come over here somewhere and accurately pop a hole in there and then find that center line from this projection and intersect it. Not a big deal. I'm going to make myself a helper block out of this. This is a leftover from a job we did a while back, and instead of milling an entire channel out of a part, drilled 2 holes, bandsawed it out, and now I have a bunch of these laying around, and that's a fairly substantial chunk of aluminum right there. So give me a couple minutes. I'm going to make a nest for this, and the nest is going to serve 2 purposes. It's going to allow me to find that inner surface, and it's also going to support the drill as it passes through the back wall. It'll pass through support material in the middle and hopefully stay straight and come out right there. Sounds good, right? Let's see what happens. Sketched up a little prelim here. Throw in the machine. Make it happen. Watch this. All right, with a little bit of material removed from that block, this is what I ended up with. And let's see if we can go over the logic behind this guy. The inside surface right here where my thumbnail is, that will be the banking surface for the milled surface I'm about to put on here. So we'll fit down in there like that and slide forward, and that'll be my banking surface. I'll have a block in the center to support the small drill as it traverses the opening in between the casting, come out this side, and the same thing in the back for the long stretch that comes through from the back here through that web that intersects the hole that I'll put in from this side. So I have a support block, an opening to clear chips, a support block, and then the actual wall that will need to be hit. And I'm coming in that way because the collective distance is shorter coming in from this side than it would be coming in from the front. All right. Got a rail in the back to locate the thing true and square. Opposite the PM Research raised letters like I planned on right from the start. So let's hang this thing upside down in a pair of tall jaws. Knock that center out right there. Maybe some of the other ugly that's in there if there's any left. And then we'll put it in this fixture, finish up the holes. Move on to the table. Let's do it. Using the tall jaws, going to invert the part, register the part against some parallels stretched across the jaws. And although you can't see it right now, I am going to close this vise using my elbow ever so gently. All right. Let's pull out here for a second. I preset the gap on my vise so that the rotation of the handle would be slightly up or up beyond center. If you have a part that'll maintain the pressure, put the long handle on that the Kurt vise comes with and just let gravity do its business. Give it a little bump and let the handle fall and lock the vise for you. When I was setting up the part, I came down with my elbow and gently bumped the handle to close it, effectively having 3 hands. But in this presentation, this gives me everything that I need to get to that marked surface in there and true it up. So let me make sure this is adequately supported. I'll change the camera angle so you can see what I'm doing, and we'll knock that web down to just clean up because it's right at the reference dimension on the print at the low spot. So we're just going to clean it up. web is now down to the reference thickness on the print. It is a clean, articulate surface. There will be a rotating disc on here that moves the belt positioner, so that does need to be nice and smooth. I took it all the way down to the bottom surface without actually cutting the surface. I didn't want too many witness marks of the cutter being down in there. I may blast this, I'm not sure. If I do, I'm going to mask this off so this is still nice and smooth. But once all the black comes out of there, we'll see what it looks like. I'm going to take it out, put a fixture in this setup, locate on the fixture, and we'll see how those bosses work that I just machined previously. Let's take a look. Now it's time to get to use the nest that I produced. The pressure from the nest will be bumping against this interior surface right there where my index finger is pointing. That vertical surface will be my 0 on the X. I'm going to push the part up against that surface and the jig up against the stop. So in all in one motion, I don't have to worry about anything being away from a registration surface. All the pressure is in the direction of clamping, so that's a good thing. Going to pick this surface up because I can't touch that surface on the actual part. So let's drop the edge finder down in there, find that surface, make the offset, and actually load the part in there. I think it'll make a whole lot more sense when you see it. Let's do it. Not just a camera problem either. I can't see it either. Hang on a second. All right, that's better. The light that I'm using to do that is called a Loupe cube. It's a really small, super bright 5-power magnetic. Stick it anywhere you want, and that thing will blind you too. It's about 2 feet away to the left. I make the offset of half the diameter of the edge finder and the dimension on the print, which is 406. So that is 506 total. Going to zero out the digital, we'll drop the part on there, and you'll get a pretty good idea of what these slots are all about. Okay, the rib on the inside, which is actually inaccessible from this setup, without this plate or a projecting pin or some secondary assist mechanism, you're just not going to find that rib. And as much as this looks like a bunch of overkill, it could have probably been done with a plate with a pin, but you wouldn't have the guide surfaces for the small drills. So I'm going to have to zero off this surface and come on out, and we're going to drill blind through that, all the way through that, and hopefully at the end, we're in the right spot. Let me set the drills up, away we go. Both of these 1/16 diameter holes will require an extended drill, so if you don't have one before you start this feature, you might want to invest in one. A 3-inch drill should do the trick for you. Go with a 4-inch and you can always cut it back, right? You can see the benefit of the guide block material that was on the fixture. Keeps these drills perfectly aligned and is a really recommended way to do this. Rotate the fixture 90 degrees, go to vertical. The center line for that hole will be the same coming in from the back. So realistically, I don't have to do any more edge finding to find the location of the center line of that hole on the Y-axis. The X I may have to tram based on the print, but the height of that hole from this surface right here is already set. Just rotate the fixture. Simple. The y-axis setting is exactly the same from the side approach. The fixture's been rotated 90 degrees. I am still pushed up against my elevated fixture surface and banking on the same surfaces as I was in the previous op. Just sitting on parallels at the 90. Going to start with a center drill in the back and watch for the drill to pass through the support material here before it gets to the final wall down here. This definitely will be a 2-drill operation. Now this is that one hole that's going to cost you an extra couple of dollars if you think you're going to do it without an extended drill. That ain't happening. They did indicate the casting left to right, tranned it, just to get a visual, and let's see what happens. Here we go. Fingers crossed. This is a 1/16 diameter hole, and it goes about 2.5 inches deep by the time you're done doing this. Now, I've explained this in the past. When you're doing a hole this deep, don't start with a long, flimsy, extended length drill to start. And there you go. That's the changeover to the longer drill. The first hole is already through the guide block. I'm going to come through the second guide block, pecking away at it to make sure the drill's on location. And then we're going to have to figure out exactly how deep to go because it all feels pretty solid right now. I'll explain that in a second. Okay, here's a tooling tip for you. Since this block is resting against the solid surface, the rib that we're drilling through is resting against the solid surface. When this drill finally breaks through that solid surface that you are, when this drill breaks through the rib that we're looking to break through, you can't feel it break through because it's now drilling into the guide block that it is resting against. So get a good visual on it, look at the quill stop, take your measurements from there. Right there. Going another 1/4 inch from right here. Let's see what happens. Pop it out, put a couple of pins in there and see if everything lines up. Fingers crossed. Going to the bench. All right, as far as I can see, the machining on this guy is complete. I opened this up an additional 30 thou, 15 on either side because I'm going to put washers in there to reduce the friction. I'll do the same thing on the outside. Got to imagine there's some kind of dimension on these tanks just with the table jumping up and down like that. I can't imagine that they're not going to look for a more precision interface than the raw casting on raw casting. So we'll find that out down the road. Cleaned up the face of this lug. If you saw it in the previous machining video, you probably were barking at the screen going, good God, Joseph, fix that. So I had to fix that. Just took a dust cut on it. Side holes, let's take a look at the side holes where they ended up. I was pretty pleased with that. That's an awfully long way to go with the drill unsupported, so make sure that you do something to support the drill. Let's get that shadow out of there, if possible. That's money, honey. That is right where that's supposed to be. That little fixture, this guy, you know, sometimes it just takes a little while to get to where you need to be, and it is so worth it once you get there. This was an invaluable piece to have to rotate this around and to get those holes to line up. The support, the extra support material for the drill, that's always a good idea when you have to go across such a long distance like that. And like I said during the actual video, when you set it up to machine that face in there for the feature that goes in there, jump around the back and just dust off that rib right there, because that can be a real problem if the drill hits that. And you can see it hit it square on. It's a good thing there was support material. Peck away at it as well. Make sure that the drill has a fighting chance of going in straight. Aside from a little blasting, this piece is done. No more machining to do on this one. 2 tapped holes at assembly, but I don't consider that machining. That's at assembly, so we'll do that later. Let's move on to the table. Came out well. I like it. Next piece in line is the table, and this is a fairly straightforward. There's going to be just a minimal old guy tricks on this, and one of them that I can see right away, if I can focus that for you. All right. This is how the part is sitting in this view. Not a big deal. And in this view right here, this is how the part's sitting. Now you can see that they expect some type of symmetry to a feature that you can't access. So while the part is in this setup right there, I'm going to probe this pocket. I'm going to probe these end tabs, make sure everything is symmetrical about a center line. I'm going to pop a hole in the center of this plate. There is no hole called out here. And the maximum hole you should put in there is a 376. And what that's going to be used for is when I flip back over, I can indicate that hole and I can know right where that feature on the reverse side is. So when I mill the throat plate pocket, it looks exactly like the picture. It's always good when the part looks like the picture, right? Part is rather thin. 125 thick, 1/8 of an inch, 3 millimeter-ish. And the only danger with a piece like this is, well, actually 2. One is going to bow when you squeeze on it. It's going to crown or it's going to cave in. And that's going to show up as an inconsistency when you measure the part after the fact. And it's going to have a tendency to ring. And you don't want it to ring because getting chatter out of something this thin, that could really lead to a problem. So what I'm going to do first is I'm going to hit all these edges with a file. I'm going to hit this large face with a file until I'm relatively sure I have something I can trust. Then I'm going to mill these sides square. I could probably leave it as cast, but when you go to squeeze something with a draft on the side, the draft will have a tendency to influence which way the part goes under pressure. So try to have square corners on something this thin. And we're going to also back it up with some heavy foam to absorb some of the vibration. Additionally, I'm going to make sure that my fly cutter that I'm going to use to clean off this surface is big enough that I can get all the way across it with the tool beyond the diagonal size of the plate. Why are you going to do that? Well, because there's no sense in going all the way across the plate this big and then all the way across it again. So as soon as the fly cutter closes, completes the cut on one side, that's the end of the cut as far as I'm concerned. So I'll extend this tool out a little bit further, make sure it's nice and sharp so it doesn't ring too much. And that'll give me a nice single radius pass across the face of this. Make it look like it's Blanchard ground. All right, let's do it. Let's hit this with a file and then put it in the mill. Before I get too carried away with the file, I figured I would show you exactly what I'm looking at. Now you can see how the file is making contact with the outer edges of this plate. That would tell you that the center is low, or that it cooled. When it cooled, it bowed. If you are using a file and you are wiping this part with a file, and you are not sure whether or not your file is curved, which means it's only going to hit this side and that side, flip it over and see if you get the same result. If you get the same result, well, you can trust your file. Now, I have noticed on certain files, and it doesn't matter how quality they are, I have actually noticed this, that if the file is going to have a bow to it, it's going to be this way and not this way. That's just how it works out. So, good thing to keep in mind. If you're filing and you're seeing this, that could either be the way it cooled off, the casting, the shape of the surface. But if you're not sure if it's your file, flip the file over. See that in real time? Watch. Flip the file over and see if it starts to clean up the center. It's cleaning up right here. But why is it doing that? Well, because there's ribs in this area, and I would think that it probably cooled it differently. Or maybe the mold itself was different. Who knows? Anyway, I'm going to continue to do this. I'm going to look for these shiny areas to get closer to center, indicating that this part is getting more flat. Don't work it in one direction. Work it diagonally, work it this way, work it that way. It gives you a better chance of getting a flat part when you're done. Then we can go to the mill, push it up against a single jaw, and clean these up. Back to the file. Got the table in the vise backed up with a 1-2-3 block, which just extends the height of the rear jaw up to 2 inches. Single pressure pad in the center. I am going to cut left to right. That way the rotation of the cutter, if there is any chipping, the chipping is on the underside of the table and not the top, which is the most cosmetic. 4 sides, moving on. Okay, keep in mind when you flip the part over, you do not have to change the Z height of the cutter because you are resting on a solid surface on the back, and that's never going to change. So just flip it over, take a dead pass at the same one to see if you were sitting on a high spot, and go from there. Now, I know I'm going to get some comments on this, so I'm going to address this before the comment string blows up. For rigidity, the ideal cutting direction would be from right to left because of the elevated rear surface. This way I am technically pushing it away from the support material, but the support material is there for more of a vertical reference rather than a strength reference. Okay, so keep that in mind. Right to left would push it against the higher, which in a thinner material would be the preferred way. But I'm not abusing this, so my way will work just fine. Now here's a change of plans midstream. If I put a reference hole in this right now, which I can easily do later today or whenever, if I put a reference hole through that right now, as the fly cutter comes across the other side, it is going to hit that hole and it's going to change the load on the tool, and you're going to see a rainbow on the back side of that hole because the tool is going to be clinging or ringing from hitting that hole. So if you've ever fly cut across a surface that has interruptions in it, you know exactly what I'm talking about. It looks like little ripples in the finish. So for sake of preserving the finish on the opposite side, I am not going to do that right now. I'm going to establish a couple of flat areas on the outside. Then I'm going to put the fly cut on the other side. Then I'm going to do this side. Only way to do it if you want the utmost finish on the other side. No interruptions. Almost got me. Moving on to the fly cut operation, I need to take this down to 1/8 of an inch above this parallel. Well, in order to know whether or not I can take this to 1/8 of an inch above this parallel, depth mic from the solid jaws in your setup to the top of your parallel. It should be less than your 1/8 of an inch or your tool is going to encounter the jaw. When I put this in, I will not tap it down because if it's bowed right now and I tap it down, it's going to flatten. And when it's unloosened, it's going to pop again. So don't do that. Gentle pressure on this. I don't want this to crown or distort in any way, shape, or form. And the fly cutter is set to exceed the diagonal dimension of this part. Let's cut it. If it rings or I don't like the finish, I'll put some foam rubber under the bottom to absorb the impact. Okay, I think you can tell the benefit of having the cutter set bigger than the part. Gives you a fantastic finish. may have a little debris in the initial casting, but we're below the surface right now, so I'll just take it to the final dimension and we'll flip it over. As you shoot for your final thickness on a part like this, make sure that when you take your measurement, you take your measurement in close proximity to a parallel. That'll give you the best indication of how thick that part is. Any deviation or distortion in the part, if you're not measuring by a parallel, you could end up running your cutter into your vise. There's some inclusions in the casting which give me a couple of track marks. You can feel it, but not too bad. That makes it look authentic, right? 1/8 of an inch thick. Going to deburr it, flip it over, do the work on the other side. I had to put the camera on charge for a couple minutes. In the meantime, I leveled off these bosses out here. It's called out as 170 on the print. There is no way that that's going to happen. If the print gives you a 125 thickness on the plate, well, there's just insufficient material on the height of these, and that is just to hold on a guide rail. So don't worry about the height of it. If you need height, put shims under the screws before you attach the guide rail. Dusted the outside of the standoffs right here, the little bosses. Cleaned them up. You know there's going to be draft on them, so I cleaned them up all the way to the top, and it took an additional 4. It is going to rock back and forth on the frame, but knowing the way I build models, I'm going to have a plastic rotational shim on either side to reduce friction. Locating the pocket, I'm using a pin, and the pin's going to go down in the recesses on either end of that particular detail. So we have a nice engagement here and on the other end as well. There you go. So once you have your pin in those scallops on either end, and that's for alignment for the blade throat plate on the other side, I'm going to move over to the center, put a reference hole. So when I flip this over, I can locate the X-axis location. Being the setup that it is, when I flip it over, I'll maintain the back edge of this table against the back edge of the vise, and the Y-axis will already be set. Simple, right? Let's do it. Now here's a trick I use quite often. If you know your vise is tight and your stationary and movable jaws are the same height, I span a 1, 2, 3 block across those jaws and lift the part up against it. So I'm lifting the part against the block and pressing the block down against the jaws. This puts the top of the part right at the top of the jaws. With a pin inserted in the previously reamed hole, I can indicate that pin and put myself on location for the next pocketing operation. The throat plate pocket is going to be put in with a 4-flute 093, a 3/32. That's about what, 2 1/4 millimeter end mill. This is a 4-flute end mill. I don't like using 4-flute end mills on aluminum. I'd rather use a 2-flute. 2-flute high speed actually, but I don't have one this size. I am creeping up on this, taking about 20 thou per pass. I don't want to load up the cutter. I don't want to influence the part at all. Staying at about 5 thousandths away from the final geometry of the pocket until I start seeing daylight through some of these cuts. This cut's supposed to be about 62 thousandths deep. I ended up going about 65 thousandths before the casting gave away. And you'll see at the very end the remnant islands being formed in the center of this pocket. Needed to be released on the ends, and you got to creep up on that, because when you have fragments of material jumping around next to an end mill that small, if they get together, that could be a real problem. The last thing you want to do is break an end mill and leave some type of witness mark. You can see the center's falling out, and I'll take the ends off right here. And as it starts to jump around, your part rate's going to go up, so get a pair of tweezers and pull that out of there and do the same thing on the other end. Well, one of the final elements on this table is to put the actual pivot pin in. And I think the pilot drill is stout enough not to deflect once it hits the bottom. I'll peck away at it until I see the drill standing still. It's given dimension off of this surface right here with an edge finder out. And then I visually aligned it left to right with the gauge pin. Let's drill and ream it. After all said and done, this is what you can expect. Got the slots in there for the miter. Table looks like a Blanchard ground finish, which is exactly what I was looking for. Be really careful if you're going to do that with a fly cutter. This is very soft, and if you track this with an indicator, you're going to leave a witness mark on it. And then, you know, give a mouse a cookie. You start with the abrasives, and you don't have that finish anymore. I did make a change underneath. Let's see if we can zoom in on that and show you. As opposed to putting a grub screw in one of these standoffs for the pivot of the main table, pivot axle or shaft or whatever, put a brass collar in the middle, and that brass collar will engage the shaft that's going through and allow the 4 points of contact to just float freely on that shaft. So that's a change that I made. I'm going to stick with that. I think that looks okay. And some of the dimensions on the print, you're going to have to figure out which ones are important and which ones are not, because you cannot have everything that they tell you to get. It's just not possible unless you remachine all of these pockets, and I'm sure you don't want to do that. I know I didn't want to do that. A couple of small holes here for the rip fence, or it's going to be a guide of some sort back here for the fence. That's all we got, guys. Next thing I'm going to attack, I'll attack the shaft mount castings up here and the shaft itself and the drive wheels, and we'll see what happens from there. But thank you very much for spending some of your time with me today. I do appreciate it. Wherever you are in the world, hope you're well, happy, and safe. All the above. I am Joe Pye, Advanced Innovations in Austin, Texas. I'm out.